Welcome. Today, we're going to present another webcast in a series of webcasts on the RSP-Z2. Today, the webcast will focus on v.4, SIP and RTP enhancements. My name is Carol Hollingsworth. I'm the Vice President of Sales at JPS. With me today in providing the presentation is Iggy Brigado. He's the Senior Solutions Engineer from San Jose, California. Iggy, would you like to elaborate a little bit more on the SIP, the SIP, and the RTP enhancements that we're going to provide a webcast on today?
Yeah, Carol, thanks. Yeah, we're going to talk about the SIP enhancements in the new version 4.1 and 4.2 of the RSP-Z2 dual channel gateway. JPS had introduced SIP, Session Initiation Protocol, which is a VoIP telephony protocol in our gateways back in the early 2000s. Things have evolved. I think we've simplified the process, which allows radio communications to interact and collaborate with telephony users, particularly over digital SIP protocol. Carol, before we proceed, I want to go ahead and show our viewers where they can download the firmware. And if you go to our website, particularly our products link, and if you want to go to the RSP-Z2 specifically, there are, again, links for that. And if you scroll down, lots of great information on this page, lots of use cases, lots of description of this product. But at the bottom of the page, there are some resources, manuals, for instance, and you can download the firmware directly from this page, and it'll direct you to our customer support site. And this is a description of the RSP-Z2 firmware. And again, if you are running versions 1, 2, or 3, you might have to do different levels of update to the gateway prior to migrating to 4.0. So the version 4 level of your RSP-Z2, all subsequent updates will be done normally through the gateway itself. So check out the website for that.
So, Iggy, if the upgrades need to be done in order. So if someone has an older RSP-Z2, they'll have to go through it and update update their RSP-Z2 for each firmware update in order, correct?
Pretty much.
From an older one up to, yeah.
Exactly. You can't go from a version 2 to a version 4 immediately. You need to do this in phases, work your way up to, if you're down at version 1, you'll have to work your way up to the version 2, then version 3, and then do the migration.
And we always inform our customers about a firmware upgrade being available. So it's a good thing to be on our email list. If you're not on our email list, please let Iggy or I know, and we'll make sure that you get on that list so that you're informed when we do have a new firmware upgrade, not just on the RSP-Z2, but on any of our products.
Yeah, that's a good idea, Carol. All right, I want to go ahead and get started. I want to talk about these SIP enhancements that I'm pretty excited about. So, Carol, before we proceed and talk about these enhancements, I want to talk really kind of basics in terms of what SIP is. And SIP stands for Session Initiation Protocol. It's a digital telephony protocol that allows endpoints like digital desk phones to initiate, maintain, and terminate calls between other devices. And so we sometimes call this the SIP trapezoid, and you'll understand why. You'll see the actual shape of the trapezoid develop here. But in my example here, we do have two systems. One system on the left, for instance, it might be my corporate office. I might have 50 desk phones there. I might also have a manufacturing facility, which you show here on the right. That might be hundreds of miles away. But what's important about Session Initiation Protocol, or VoIP telephony, is that there's always a proxy server, a SIP proxy server, that supports all the endpoints, for instance, at the left at my corporate office. And this allows these devices to register to the SIP proxy server. They're assigned an extension number, and the SIP proxy server allows these endpoints to find each other in my local corporate network, but also over the internet using such things as stun, which I'm not going to talk about. But over the internet, we can find other SIP proxy servers where we can then identify other endpoints. And some of those endpoints could include JPS products that have SIP capabilities, and most of them do. We're talking about the RSP-Z2, which does actually have 8 SIP endpoints, and we'll talk about that a little bit more. So how do we initiate a call? So at one end, I might have a desk user dial an extension on their phone through the SIP proxy servers, what we call through signaling on port 5060. We can then contact a SIP endpoint. We can negotiate some information like data, what type of data we're going to share. And then we establish what we call a real-time transport protocol link. And this is where the voice, video, and data flows. But we're talking about RSP-Z2s. We're mainly focusing on voice. So you can see the trapezoid already has formed. We do have that signaling path where the two devices initiate and maintain that connection. And then the RTP flows. It can be full duplex, for instance. And, how do we answer these calls in terms of how does the RSP-Z2 answer these calls? There's several ways we can do this, and this is some of the enhancements we've added into the RSP-Z2 SIP interfaces. And one of those is to manually answer calls through the user interface, the web interface. We'll show you here in a moment. We can also create an auto answer or even a reject inbound call. So let me switch back to my RSP-Z2. This is my live RSP-Z2. As you can see, I am in the custom mode. And so if you followed our previous webcasts, we talked about the many different modes that we can create with the RSP-Z2. So go to the JPS Interop channel and check out those previous webcasts where we talked about the overall enhancements of the RSP-Z2. And so I'm going to go ahead and create very simple cross connections here. I'm going to move my digital protocol. This is a radio interface on the front hull of my RSP-Z2. I also have a VHF conventional. Now this conventional and digital radio can interact and share voice communications. And I do have a SIP interface that I've provisioned, and we'll look at how I did that in a moment. But I'm going to slide that into a separate interoperable net. I can even create a second interoperable net if I need to. But let's talk about this SIP interface in terms of receiving these inbound calls. And one way we can set up is to accept a inbound call. I'm just going to do one call real quick just to let you see what this looks like. All right, I'm going to go ahead and initiate an inbound call from my mobile phone into my RSP-Z2 gateway. All right, as you can see, we got an inbound call. There's an indicator on the screen, and this allows me to then accept that call. All right, so now I can have communications back and forth from a radio, which is in that interoperable net, and my mobile phone. And that's how I created a manual answering of that inbound call. I can go on hook at the RSP-Z2 and terminate that call. Remember, terminating that call through the 5060 port. Let me show you from the settings screen. I'm going to focus on one of my back calls, which is already provisioned as a SIP interface. And as you know, all these interfaces can be provisioned on the fly by selecting a different type. Again, this one happens to be the SIP interface. And this is how I manage my inbound calls underneath the call management panel. And I'm going to go ahead and set it to auto answer. Actually, this is how I prefer setting up my RSP-Z2s. In a lot of cases, depending on your mission or your needs, that might not be appropriate. But let me go ahead and demonstrate this as well. I'm going to initiate the call again on my mobile phone. All right, as you can see, the call is coming in. The call automatically got accepted. I can talk on my radio. Testing 1, 2, 3. And you can see the control signaling going back and forth between the devices. Testing 1, 2, 3, 4. And I can hang up at the far end, and you're going to see the RSP-Z2 through the signaling port. The call will be then terminated. So that's auto answer. I like that. It allows me to interact immediately with radio interfaces. And lastly, if I go back to the settings screen of the SIP interface, and if I look at the inbound call selections, I can also reject inbound calls. And so that's actually important for public safety agencies or fire service agencies that do not want inbound calls. If I'm operating my system, for instance, my policies might say that I have to create outbound calls. I can't accept inbound calls. All right, so I'm going to go ahead and reverse the process here. And so back at our example here, Carol, let's talk about an outbound call. So I want to make a call from the RSP-Z2 outbound to another telephony device. Again, this could be a mobile phone. It could be to a video conferencing platform that can support SIP. And so let's dial from the RSP-Z2. There is no dialing pad on the RSP-Z2, but we got ways of engaging through signaling to other devices remotely. Once the far end comes off hook, and then we can allow the RTP to flow in full duplex between the endpoint and the RSP-Z2 device itself. And so there are several ways we can also create the outbound call. An ability to manually dial from the user interface, the web user interface that I showed you earlier. We can also create an outbound call that's always connected, meaning it's relentlessly connected, for instance, to a video conferencing platform or a conference phone, for instance, or another device that is SIP compliant, maybe a console, for instance, or a voice logging recorder. And lastly, we can dial on transmit, which is pretty unique. So let's go take a look at the RSP-Z2. Okay, back at the RSP-Z2, you can see I've got my net set up with my SIP interface as well as some radio assets. And let's go take a look at the settings screen, particularly of that SIP interface. And let's look into the call management panel here in the center, and we can see how we can define auto dial if we need to. By default, we're set to never, but we can also configure the auto dial output to always or on transmit. So let's go back to the home screen. And since I am consolidated in an interoperable net, this gives me now the ability to click on the dial button. I can enter a phone number. Entered my mobile phone, and you can see the little bullseye indicating that a call is coming in, and a call just came in on my phone. I'm going to go ahead and answer that, and you can see now the signaling going back and forth and the audio being shared. And what's interesting, I think, about the consolidation of a full duplex telephony interface with duplex devices like radios, half duplex, is that there's going to be give and take. And there's a way we can trigger our voice information on my telephony device such that I don't interfere with the radios, for instance. So I'm going to go back on hook, and that's an example of dialing from the user interface. I click the dial button again and enter the dialing information, for instance. The other selections that we have focus on my SIP resource. And so what I'm going to do here is I'm going to select always. And this is a SIP connection that's always going to be linked to a device on a continuous basis. And it's pretty relentless. So this is going to be pretty annoying here, but I'm going to go ahead and save this. And as soon as I save that, let me go back to my home screen. You're going to notice that the RSP-Z2 is trying to call an endpoint, as you can hear here. I'm going to go ahead and go off hook on my far end, and now we can share information. Again, if I hang up this endpoint, the RSP-Z2 is going to try to engage again this endpoint. So I went on hook. The RSP-Z2 is going to attempt to make that connection again. It's pretty relentless. There you go. It's trying to make that call again. All right, I answer that call, and we have duplex communications going back and forth. So I am going to hang up, and let's see how quick I am. I want to turn this off. But it gives you a great example of some of these enhancements that we're talking about. Actually, it's pretty relentless. It's trying to call my endpoint. Let me go ahead and say never. Answer that. I'm going to go back on hook. All right, so lastly, the last call management feature we have in terms of outbound calls or auto dialing is to dial on transmit. Let me go ahead and set that up. I saved that configuration. And what's important about auto dialing is that you need an auto dial destination. And so you're going to enter a telephony extension or a phone number in this field, and that will initiate that call when you're set up with an auto dial configuration. So let me go back to my home screen, and what auto dial allows us to do is when there's any transmit activity within the net that's occupied by a SIP interface that we see here, it will initiate that call based upon that auto dial destination that we pre-provision. So I'm going to go ahead with my conventional radio. I'm going to key that radio and create some transmit activity within that net. We'll see if this thing, if it'll auto dial the RSP-Z2. All right, testing. We got activity. And
Iggy, I don't believe DTMF tones are available now that would activate devices like alarms, but is that something that may be available later?
yeah, Carol. Yeah, that's on the roadmap. We've been talking about the ability for some remote interaction using DTMF particularly from radios, and we might be doing some with the telephony devices in the future, but definitely radios. And as you can see there, Carol, I initiated an automatic call. So let me hang up again. I'm going to go ahead and do this again so everybody can see that. And this was primarily put in place to allow the sharing of transmit and receive audio with a voice logging recorder. And again, let me go ahead and create transmit activity in that net. I'm going to key my radio here. All right, you can see the core activity, and you can see that SIP icon, the tile, has that little yellow bullseye. That means I have dialed out, and I'm going to go ahead and answer that call. All right, again, we got the activity. All right, core and PTT activity back and forth. I'm going to go back on hook. So lots of great features there, Carol, in terms of SIP.
There are a lot of great features. I suspect that there are so many different uses and applications that SIP is going to become very popular part of the RSP-Z2 for a lot of the customers that we have.
Yeah. Let me show you one other feature in terms of it's really not purely SIP, but it's RTP based. And you saw on my trapezoid, the SIP trapezoid, there is an RTP flow of video, data, and voice, and so we can actually manage RTP connections without signaling. So let me show you an example of that. The front haul and the back haul has many permutations in terms of we can support radios on the front haul. We can also support digital protocols, and that holds true for the back haul as well. So we have lots of permutations, and we can create many combinations of interoperability or interaction between these systems. But you can see that we have up to 4 capabilities on the front haul and back haul, and this is duplex communications back and forth in both directions. But what we also have are 4 additional auxiliary SIP and RTP interfaces, primarily used for outbound traffic for voice logging recorder. So let me show you where that is on the user interface. Okay, we're back at the user interface of the RSP-Z2. One thing you might remember from our previous webcast, we do have an RTP or a SIP recording stream function, and you can see that in the header of the net. There's a little pull down menu here which allows me to select a RTP stream based with respect to an IP address and a port value of maybe my voice logging recorder or another device that's SIP or RTP compliant. I can select that stream, click the little button here on the top, and now I can start recording the transmit and receive information and stream it outbound only to a voice logging recorder. So if I go to the settings screen of my RSP-Z2, we can see the 4 RTP interfaces that are embedded in the RSP-Z2. They're there. You can turn them on or off anytime you want. But those RTP interfaces, which can also be configured as SIP interfaces, as you can see here in the pull down, are the 4 auxiliary outbound-only RYP paths. So let's go back to my diagram, and I just want to explain a little bit more about the interfaces. And there's essentially 8 SIP and RTP interfaces in the RSP-Z2. And so you can see here that we do, in fact, have 8 SIP or RTP resources, depending on my mission or requirements. I have a lot of SIP interfaces. I might not want to use them all, probably will not need to use them all, but you can see the flexibility, again, of this RSP-Z2. And one thing I wanted to illustrate is an equivalency to the RSP-Z2, because that RSP-Z2 has up to 8 SIP interfaces. I'm going to equate that to 8 digital telephones that might be in a corporate office, for instance. And what's interesting thing about these digital telephones is that they do have unique IP addresses. But what's unique about the RSP-Z2, it only has one IP address, which is going to support 8 SIP resources, which is very unconventional. And so we have the signaling port, the 5060, which my telephony devices use, and the RSP-Z2 also has to use But because I have 8 resources in the RSP-Z2, I have to somehow share or multiplex that signaling through that 5060 port, which can become complicated. So the way we differentiate the 8 or up to 8 SIP resources in the RSP-Z2 is assign them usernames. So anybody that's a Cisco Unified Call Manager administrator, we typically call that the directory number or the extension. All right, so that's how we can multiplex the 5060 port signaling to one IP address, but still support up to 8 resources. So I just want to differentiate that. Lots of versatility again in this gateway, but it's there for you to use. Remember, we got 4 duplex SIP connections and 4 outbound one-way connections where we can stream SIP or RTP from that gateway. Let's talk about RTP. You know, as we mentioned earlier, RTP, real-time transport protocol, is where the voice data, video data, and other data flows between the SIP endpoints. And when we're dealing with RTP, or the RTP stream specifically, is that we don't need SIP proxy servers. We don't need the signaling protocol that is normally used for session initiation protocol, which is SIP. So we don't need to initiate, maintain, or tear down those connections. The way we do this with RTP directly is by using an IP address and a port value of the far end that I want to share RTP data with. So we don't need that signaling path. It's a persistent point-to-point connection. It's not as convenient to initiate as a SIP connection, but it's still a reliable way of sharing RTP information. So again, if I want to share it to an RTP appliance that is compatible with RTP and I want to stream that information in full duplex, I do have that capability. This is my RTP interface, and there is, again, we're not implementing a SIP proxy server, so all we need to do is enter the IP address of my destination and the port value of that RTP stream. Go ahead and select that and go ahead and save that configuration. And one last thing I want to talk about, which is SIP related, and we talked about this in our earlier webcast, is under the audio control panel, is we've added the ability to adjust the receive gain. This is actually the digital gain inbound to the gateway. We have ability to boost 26 by 26 dB or cut by 26 dB the audio level. So why is this important? It allows very precise gain staging of these devices. There might be several hops or different devices in my audio chain, and this gives me that fine granularity in terms of setting the gain properly with each subsequent hop through different devices. So really nice way of gain staging. And we can do that on the SIP side. Really all our digital protocols, we can adjust the gain.
Yeah, it is incredible. The amount of new features in the RSP-Z2 after the migration to v.4 is awesome. This, and as you stated, Iggy, this is the last in the series of the migration webcast to v.4 on the RSP-Z2. All of the previous webcasts can be found on the JPS website at jps.com. So in future webcasts, Iggy, are we going to address some of the other products and the applications that they have, and perhaps new firmware upgrades?
Yeah, absolutely, Carol. I think what we're going to do, we can talk about the RSP-Z2 forever. And as you mentioned, we are expecting a new build here shortly. And so we're probably going to revisit the RSP-Z2 from time to time as we add new features. And really by the end of the year, there's going to be a lot of new features. But what I think we want to do, Carol, and I think you can agree with me, we're going to focus on the Z series controller and talk about wide area distributed architecture, where we can take a multiplicity of gateways, not only RSP-Z2s, but ACU-Z1s and NXU-2Bs and even our legacy gateways, and marry all those devices into a single platform by employing a Z-Series controller, which is our, so to speak, management hub. And we're really excited about that because it adds a new level of control of these gateways from a singular platform. So
basically,
pretty
a system
pretty
of
exciting.
systems. In the RSP-Z2, the applications for that is endless. At least as insofar as it has been, they are absolutely endless. And we look forward to doing these other webcasts. They're going to be, I think they're going to be very versatile. The applications, again, are going to be really wide and varied. It covers so many different markets out there that use these types of products that it's going to be fun to do, and I look forward to doing them.
You know, Carol, can you give me one more minute to talk about one more thing? You know me, I know you too,
Sure.
and we can just keep going. But I want to talk about one thing because some of the viewers might have noticed a fifth tile in my resource panel on the left. I haven't shown that in the past, but it's labeled as headset, and this allows me to move this headset into an interoperable domain or a net, move it around, whatever, and apply a headset to my architecture. So the RSP-Z2, if you remember, has USB ports, one on the front and one at the rear of the device that can accept a USB headset or a USB wireless headset cradle, for instance. And this then again allows us to add a headset resource into the mix here. And so as you can see, I've got my headset in a net, and this now allows me to collaborate in duplex with a resource. And so one of the things I like about this is maybe I might want to use this for troubleshooting purposes. So let me look at some of the settings of this headset very quickly here, Carol. Go back to the screen here. I've got my headset focus, and we have a selection here under audio control for that headset is how do I detect that I have audio going into the headset from my headset mic. And we have several selections here. And by default, we can use Vox, we can use voice modulation recognition, but we also have a way to use the web user interface with a PTT toggle function. So I'm going to go ahead and save this, go back, return back to my home screen, and you're going to see that there is a PTT button, toggle to talk. So I'm going to go ahead and press once, and this allows me to now start conversing. My headset's near something very noisy, and I can stop that toggling. And once we start talking about wide area systems in our next webcast, this might become a handy tool in terms of troubleshooting. All right, Carol, I guess we're going to wrap this up, our discussion on SIP and RTP enhancements. Again, if you have any questions, give Carol or I a call, or direct your calls to the facility there in Raleigh, North Carolina.
Excellent, Iggy. Thank you so much for doing this today. And we look forward to seeing you at the next webcast. And we've got a lot more exciting webcasts to come, and we look forward to presenting them to you. And we thank you very much for being with us today.
Great. We'll see you next time.